In this section, we are going to be solving equations and remembering that these are review problems from previous courses that you've had in math. An equation is an expression that has an equal sign. So as long as it has an equal sign, it will be an equation. Less than, greater than, those kind of symbols make it an inequality, not an equation. A solution is a value that makes the equation true. So if you substitute in the value, it will make the solution a true statement, or it works. Make sure that you are always checking for extraneous solutions. These are extra answers. So after you solve it, when you substitute it in, it does not work in the original problem. I will have an example of that later on in one of our problems. Always, whenever you're solving, is to keep the two sides balanced. So whatever you do to one side, you must do to another side. We're going to start out by solving a linear equation. A linear equation has the value is in the form of ax plus b equals 0. Now you might not have a b, it might be just something like 2x equals 0 or 2x equals 5, etc. But you can always get them equal in this format. Our first example, we have to solve 3x minus 9 equals 5x plus 13. I want to quickly show you, because we do have an option with this, and to see it as two separate linear equations. So I could do 3x minus 9 and 5x plus 13 on our calculator, and graph those, and the two lines are going to appear. And when I look at this, it looks like, oh, my intersection is not appearing. So you could do a zoom, zoom in, a zoom out. Obviously, we don't want to zoom out in because ours is not showing up. So we could try a zoom out. And if you use the arrow key, you can kind of scroll down to getting closer to where we want to zoom out, and then do enter. So we can do that, and here the intersection starts appearing. A better suggestion is to adjust our window. So I'm going to go to -10 for the x's. We'll go to 3 because it doesn't look that far over. -50 to 10, and I'm going to go by tens. So I'll try that. And over here, mine actually does show up. You're going to have to hit graph. So it looks like, oh, it's not quite working. So I'll go up. Let's do -15 and graph it, see what happens. So we're looking for when are those two the same? And it looks like the intersection is right here. Your calculator will calculate that for you. If you do second calculate, intersect. First curve, make sure it says the first equation up top. Second one, make sure it says the second one. A guess will make it go quicker. So if I scroll over here to where it looks like it's crossing, because all the calculator is doing is substituting numbers in and getting numbers back. So they're intersecting at when x is -11 and the y value is -42. What that means is if I were to plug -11 into each side, I would get a -42 on each side. So that's how you can do it graphically. But to do it algebraically, we want to get the variables together on one side. So I'm going to subtract 5x from both sides. That leaves me with -2x and no x's on this side. Actually, I could combine steps here, add a 9 to both sides, and get a 22. So if you want, you can tell those would become 0, those would become 0. I'm left with this. Divide both sides by -2 because it's -2 times x. So I get x is -11. You should always check these by just substituting the values into the equation. So to check, you would do 3 times negative 11 minus 9 and check to see, does that equal 5 times 11 plus 13? Which would be negative 42 equals negative 42. So it does in fact work. So x equals negative 11 is our solution. Now I'm not going to take the time to check all of these. There are particular ones that I will show the check for. The next problem, we have 5 over x plus 1 over 3x equals 7. Now most people don't like to deal with fractions, and that's okay. We're going to multiply to get rid of it. So what I do is I just start to look at the denominators. I have an x on the bottom, so I'm going to get myself some space here. I'm going to multiply in order to get rid of that x. So I'm going to multiply everything by x. So I have to keep everything balanced. So here, x divided by x becomes 1. Here, x divided by x becomes 1. So those divide out. Then when I'm looking, I see, oh, I still have, so just moving over, I have a 3 on the bottom. So multiply everything by 3. And on this one, our 3's divide out. So what I'm left with is 3 times 5 plus 1 equals 7 times x times 3, which is really 15 plus 1 equal to 21x. And 15 plus 1 is 16. Divide both sides by 21 to get the x by itself. I'm just going to rewrite it, and it doesn't matter if it's on the left or the right side. I prefer it on the left. So I get x equals 16 over 21. And again, you should check these, but I'm not going to take the time to show you how to check because I'm confident that you know how to substitute numbers in and divide. Our next type of equation that we're going to work with is a quadratic, which is in the form of ax squared plus bx plus c equals 0. Now remember, you can move numbers over to everything to one side in order to get that equal to 0. This first one, I have a couple of options. This one is unique. So I could move the 81 to the right side, divide both sides by 25, and then square root both sides to get x equals, and whenever you take the square root, you should do positive or negative. Square root of 81 is 9, square root of 25 is 5. I can also use the quadratic formula, which you might call, and you can look it up online. You can do it to the tune of Pop Goes the Weasel. So if I use same problem, but with quadratic formula, I would have a is the coefficient of the x term, which is 25. B is the coefficient of the x term. There isn't one, so it'd be 0. And c is the constant, which is a negative 81. Don't lose that sign. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which will simplify to, see, square root of 8,100, which would be 90 over 50, which reduces to 9/5. Same answer, 2 different ways of approaching it. Both are completely valid ways of doing the problem. Now when we get down to a different one, our next quadratic, we have 12x squared minus 11x minus 5 equals 0. So I can use quadratic formula. So x equals negative b, change the sign, plus or minus b squared minus 4 times a times c. And just like the last section, you have to make sure that when you're doing the squaring of that negative, you put it in parentheses, and that's all over 2 times a. Now you can calculate all of that underneath that square root, and take the square root, and you get 19 over 24. So I have 11 plus 19 over 24, which is 30 over 24, which will reduce to 5/4, or 11 minus 19 over 24, which becomes negative 8 over 24, which become negative 1/3. So quadratic, you should have two answers on all of these. The exponent of the x will indicate the number of solutions. I could also solve this problem by factoring. Since it is 3 terms, I can put it into 2 groups of 2. Some of these you might have to do a little bit of guess and check. So 12, I think, well, how about 3x and 4x? And then 5, it's really only 5 times 1. So now if I check this, I already have the first would be 12x squared. Outside would be negative 3x. Inside would be 20x. And last would be negative 5. So when I check that one, the middle two don't work. So I can do some rearranging. So what if I switch these around? I don't remember which one I had where, but if I switch them around here, now if I checked first, outer, inner, and the last, this would give me the negative 11x in the inside. So I'm happy about that. So those are my 2 factors, so make sure those work out. And if you're multiplying the equals 0, that means one or the other must equal 0. Subtract 1 from both sides, divide by 3. X is negative 1/3, or add 5, divide by 4, or 5/4. Same exact 2 answers. So I'm feeling good about those. Now, there's another method to these, and that is completing the square. I did pick a more complicated problem for completing the square, but that's okay. First thing we're going to want to do is get anything with an x on one side and move the constant to the other. So instead of minus 5 equals 0, I just move the 5 over. Do leave a space. I do have that for a reason. Then you're going to divide the 12 out of that side. Now, at this time, you could take, and I'm going to because I think it'll make it easier, divide both sides by 12, so it become 5/12. So now if I were to rearrange, so move that 5 over and multiply everything by 12, I will have the same exact statement. So far I'm only manipulating to get in the form that I want. Now to do the completing the square part, what you're going to do is add the same thing to both sides. Remember, just keeping it balanced. And you're always going to take that middle term, b divided by 2, and squaring it. So I could do the 2a, but remember I already took care of the a by dividing that 12 out. So this one, 11/12 divided by 2 is 11/24. So that's actually what you need to do, the difficult part for completing the square, because now after that, this side factors because it's a complete perfect square trinomial to just 11/24 squared. So if I were to FOIL this black part, what I have right here, it will become the line before. And I've already did a little bit of the work for us here, but if I do the 5/12 plus 11 over 24 square, make sure if you're doing that on your calculator, put parentheses around it. I would get 361 over 576. So now what I can do with this one is square root both sides to get rid of that square. So I'd have x minus 11 over 24 equals, and I took the square root, so it will be plus or minus 19 over 24. Add that 11 24s, and we'll notice that it now just took the same exact form as our quadratic formula. You can derive the quadratic formula the same exact way I just did, but with the letters A, B, and C. But that is typically something that is covered in an Algebra 2 class. I'm sure if you search online, you can find that. And I am also very happy to show that to you as well. So that's 3 different ways of doing the same exact problem. Remember, you should always check your answers. These do in fact work, so if I substitute them back in, it will work perfectly. So we have a few more down here, so there's some other types of equations. We have a polynomial here first, and the easiest way to do this first one is by factoring. This part of the book does not focus in on the whole, if you remember from Algebra 2, P over Q, if that sounds what familiar. So this one has 4 terms. The first 2 have x squared in common. So if I divide out x squared, that leaves x minus 1. Divide out a 2, that leaves x minus 1. And so now these 2 have something in common. Let me find my highlighter. There we are. They both have the x minus 1 in common. So what I can do is then factor out the x minus 1, and what's left behind is the x squared plus 2. So now I have it down to a multiple of multiplication, and whenever you're multiplying and they equal 0, 1, or the other must have been 0 to start with, add 1. So x could be 1, and when I substitute in the 1, yes, it does in fact work. This one, subtract the 2. Now come down to, well, what do I do if I am square rooting a negative number? Remember, square root of negative 1 is I. Add a little bit of space here. Took the square root, so it's plus or minus, and that would be I square roots of 2. Now you can check this on your calculator, so let's grab our calculator here and go back to our regular screen. You'll first want to go to mode and go down next to real. Make sure the imaginaries are on, so a plus bi. So again, that was in mode. Then quit out of there. The easiest way I think to do this one is to do the I, which you can do second period is I square root of 2. So plug that one in. Oops. And it's going to give you a number. Notice it does have the I at the end. So now if I look at my equation, I took that to the 3rd power minus to the 3rd power minus that squared plus 2x minus 2. And I get a 0 back. So it does in fact check out. I can do the same thing. I could do the negative I plus, or I squared of 2 and do the same exact thing. So if I do negative I square root of 2. And now you're thinking, oh, I have to type that all over again. You can do second entry, and it will do all the same calculations again, but with the new answer. So both of those do in fact work. And remember, I told you that the exponent will tell you how many solutions there are. So we're going to notice with this one, I had x cubed, and I got 3 solutions. So x is 1, I square roots of 2, or negative I square roots of 2. All 3 of those answers do in fact work. If you come across a problem with square root in the original problem, you first want to isolate the square root. So get the square root by itself. Just like that. And then you're going to square both sides to get rid of the square root. The important part with this one is when you square the part that is a binomial or something bigger, binomial just means it has 2 terms, you're in fact squaring it. So this really means I'm taking x plus 1 times x plus 1, which means I need to FOIL it. So I'll get x squared plus 2x plus 1. I like to have things on one side. So I'm going to have the x squared here on the right side. If I subtract 2x from both sides, these two actually become 0, and also subtract the 1. So I get 2. So I have x squared equals 2, square root both sides, and that would leave me with x is equal to plus or minus the square root of 2. Now, particularly with these, you'll want to check for extraneous solutions. You'll want to substitute the values in. So we go back to our calculator. We have square root of 2. So my problem was square root of 2 times x plus 3 minus x should equal 1, which it does. So now if I go back here and insert a negative square root of 2 and do second enter, the second one doesn't work, and that's okay. So that's an extraneous solution. So really, there's only one answer. So that is extraneous. That's how I abbreviated, ran out of space. The negative square root of 2 is an extraneous solution. So do check for those. Okay, our next problem, we have something raised to an exponent. So we have x plus 1 to the 3/2. To get rid of, or to solve those, what we're going to do is raise both sides by the reciprocal, or 2/3, because our properties tell us that for doing power to a power, we would multiply those two. So it'd really become just x plus 1 to the first power. And 4 to the 2/3 is the same as cubed root of 16. It doesn't work out evenly. I'm going to rewrite that. So subtract 1 from both sides. That's the exact answer. The approximately answer, make sure we're rounding. I always round to 3 decimal places. So either of those would be appropriate answers. If you're raising to something, so as a side note, so if this was our problem, if you're raising something to a half, you're really taking the square root, and remember whenever you do square roots, you should have the plus or minus. So if you're doing it to a 2 on the bottom, a 4, a 6, an even number on the bottom, there are 2, so you should have positive or negative. Our last problem is probably one of the more confusing problems. You could probably do it if it was just, say, absolute value. And we're going to change this problem. So that one didn't quite work out how I want it to. So we're going to change it. So if it was just absolute value of 3x minus 2 equals 1, you might know what to do. So first of all, remember absolute value from that last unit is the distance a number is from 0. So we want the distance between 3x and 2 to be x plus 1 away from. So you're like, I don't know. So we know that our root to be, say, like 4 units away, I would have 4 or negative 4, right? Both of those are 4 units from 0. So we know 1 stays the same sign, so we're going to work with that. So I'm going to subtract x. I don't like to deal with the negative, so I usually do that, and add 2. So here, those become 0. This is 3. 3x minus x is 2x, and those become 0. Divide both sides by 2. So x is 3 halves, and then I check that it does in fact work. So whenever we're doing an absolute value, you should have 2 answers, so that's one of the 2. So we did this one, right? We took care of that. We could also have the negative, right? It would be 4 units away. It could also be negative. So how that will work with this one is x plus 1, it could also be the opposite. So you just put a negative in front of whatever the absolute value was. So you leave one the same and put a negative in front of the other. I'm going to distribute that negative. So I really have this. I like to deal with positive values of x. So I'm going to add the 3x and subtract the 1. So that gives me 4x. Those become 0. Those become 0 equals 1. So x is 1/4. So x is 3 halves or 1/4. And then you check those. They do in fact work. Make sure you're always checking all of your answers for any extraneous solution. So that's answers that when you substitute in, it does not work.